All right, let's jump right into this explainer and explore the absolutely epic 2,500-year relay race behind the invisible force that literally powers our entire modern existence. Electricity wasn't just invented in a single flash of genius on a random Tuesday afternoon. Not at all. It took centuries of wild discoveries, brilliant experiments, and honestly quite a few failures before humanity figured out how to generate, control, and finally use it to light up the world.
I want you to look around the room you're sitting in right now. Just take a look. Now picture what happens if that 2,500-year-old discovery suddenly just vanishes, literally fade to black. It's actually kind of hard for us to even wrap our heads around today, right? Just because we are so completely and utterly surrounded by it.
If that invisible force vanished, well, look at what goes out the window with it. No lights, no internet. Yeah, that means no Wi-Fi at all. No refrigerators to keep our food safe, no computers, no smartphones, not even a simple electric fan to cool you off. It's just wild to think that every single one of these everyday things depends on a force that took centuries of brilliant minds basically standing on each other's shoulders to finally harness. Electricity was always there in nature, all around us, but for the absolute longest time, no one had a clue what to do with it. So, let's start at the beginning. Chapter 1. The Mystery of Amber.
If we rewind all the way back to ancient Greece to see where the story truly kicks off, you'll see that progress was, well, agonizingly slow. Around 600 BCE, the Greek philosopher Thales of Miletus noticed something super weird. When he rubbed a piece of amber with animal fur, it magically attracted tiny feathers and bits of straw. He had unknowingly just observed static electricity. But then, crickets, nothing. Humanity essentially just sat in the dark for over 2 millennia between Thales rubbing that amber and the next major leaps forward in the 1600s and 1700s.
That massive drought of progress finally broke in the year 1600. English scientist William Gilbert published this groundbreaking book called De Magnete, where he really dug in and studied both magnetism and static electricity. And here's the cool part. He coined the term electricus, which he pulled directly from the Greek word electron, which, you guessed it, means amber. That is exactly where our modern word electricity comes from. Gilbert hit the nail on the head and finally moved electricity from a weird philosophical party trick into a true, rigorous science.
Moving right along to Chapter 2, Taming the Lightning.
As we hit the 1700s, this whole curiosity builds into an active pursuit of nature's most terrifying power. Scientists became absolutely obsessed with electricity, and honestly, none more so than Benjamin Franklin. His work brilliantly shows the leap from mere theory to reality. In 1752, Franklin's famous kite experiment during a thunderstorm proved, once and for all, that the immense raw power of lightning was purely electrical. But he didn't stop there. He introduced the whole concept of positive and negative electrical charges. And he actually used those findings to invent the lightning rod, handing humanity one of its very first practical, life-saving electrical technologies.
Which brings us to Chapter 3, The Engine of Progress.
Okay, here's where the pacing really shifts into high gear. Humanity goes from just watching electricity happen to actually making it on demand. In 1799, the Italian scientist Alessandro Volta created what we now call the voltaic pile. He literally just stacked up alternating layers of copper and zinc discs and separated them with pieces of cardboard soaked in salt water. And boom, he created the world's first true battery. This was an absolute game changer. For the very first time in human history, scientists didn't have to wait around for a thunderstorm or rub a piece of amber. They finally had a reliable, continuous source of power to experiment with. The electrical age was officially open for business.
But if we're being honest, if there is one single person who deserves the credit for making modern electricity possible, it is without a doubt Michael Faraday. In 1821, he showed off the very first electric motor. Then, a decade later, in 1831, he made an even more mind-blowing discovery: electromagnetic induction. He proved that simply moving a magnet near a wire generates electricity. So, the big takeaway here? Faraday changed everything. Every single modern power plant on Earth still operates using his basic principle. Whether we're talking about burning coal, splitting atoms in nuclear plants, water rushing through hydroelectric dams, or wind spinning massive turbines, the core idea is exactly the same today as it was in 1831. Motion creates electricity.
All right, Chapter 4, Lighting the World. With this massive foundation laid down by Faraday's generators, the race was officially on to replace those dim, super dangerous candles and gas lamps with electric light. And that brings us to one of the biggest myths in the history of science. You've probably heard that Thomas Edison invented the first light bulb, right? Well, the reality is a bit different.
Earlier inventors had actually been working on this for decades. Back in 1806, Humphrey Davy demonstrated an electric arc lamp, and later Warren de la Rue built early incandescent lamps. The problem was, those early designs were incredibly expensive and totally impractical for normal use. It wasn't until the late 1870s that British inventor Joseph Swan and American inventor Thomas Edison independently took those existing designs and essentially perfected them. They made the incandescent bulb long-lasting, affordable, and practical enough to put in everyday homes. By 1879, practical electric lighting had officially arrived, and the world was forever changed.
And you know, once homes actually had power for lighting, inventors instantly saw the potential for so much more. In 1882, an American inventor named Schuyler Scott Wheeler, great name by the way, developed a fan powered by a small electric motor. And that was quickly followed by the invention of electric irons and household heaters. Thanks to Faraday's electric motor from decades prior, electricity was no longer just some dry scientific curiosity in a lab. It was actively transforming the household and making everyday life exponentially more comfortable.
Let's move to Chapter 5, the War of Currents.
So, Thomas Edison opens one of the world's first public electricity supply systems in 1882 to power all these new homes and businesses. But almost immediately, a massive clash erupts over exactly how we should power entire cities. On one side, you've got Edison fiercely promoting his direct current, or DC system, which pumped power out from local central stations. On the flip side, you have the brilliant Nikola Tesla championing alternating current, or AC power. This was a total heavyweight bout, but ultimately, Tesla's AC system became the dominant method of power distribution worldwide. And the reason is simple. AC was highly efficient for transmitting electricity over huge, long distances. It literally made it possible to power entire nations rather than just a few city blocks.
So, let's zoom back out to today. When you look at a sprawling modern city skyline, the satellites floating up in orbit, the smartphone you're probably holding right now, or the massive data centers connecting billions of people, nearly every single technology you rely on traces its origins directly back to this continuous chain of discovery. It's like a giant puzzle spanning 2,500 years. From Thales noticing a weird pull on pieces of straw, to Franklin flying a kite in a storm, Volta stacking up his metals, Faraday playing with magnets, Swan and Edison lighting up the dark, and Tesla powering the entire globe. Every single breakthrough passed the baton and helped build the modern world we live in today.
But you know what? As we look to the future of this incredible, invisible force, the relay race is far from over. We are constantly searching for new ways to generate electricity more cleanly and use it way more efficiently. So it really leaves us with a massive question. How will the next generation of brilliant minds pick up the baton and continue this race? What exactly will electricity power next? Thank you so much for joining me on this explainer, and honestly, I hope you never look at a simple light switch the exact same way again.